Welcome to Circuits and Devices Lab. In this video, we are going to learn how the experiment number 2, Zener diode characteristics and regulator using Zener diode can be performed using virtual lab. A Zener diode is a special kind of diode which permits current to flow in the forward direction as normal, but will also allow it to flow in the reverse direction when the voltage is above the breakdown voltage or Zener voltage, which is approximately 2.4 volt. So here regulator means it is an electronic circuit that provides a stable DC voltage independent of load, current, temperature, etc. So, in order to perform the experiment, Zener diode characteristics and regulator using Zener diode, we have to go to virtual lab and then select Electronics and Communication Engineering branch and then go to Basic Electronics lab. The procedure is shown in the previous video. So do the same and click the Basic Electronics lab. So here this shows the introduction of virtual laboratory. So in this page you have to select the list of experiment. So we have to perform the Zener diode characteristics. So we have to select the Zener diode voltage regulator experiment, ninth experiment. So click to that. So you can see this window. So this consists of theory part. So this is your theory page about the Zener diode. This explains the structure of Zener diode, functions of Zener diode, how Zener diode is acting as a voltage regulator in line regulation and in load regulation. So these are the equations related to Zener diode. So go through it and then go to the top and select procedure. So once you select this procedure tab, you can see the step-by-step procedure to perform the experiment of characteristics of Zener diode and also regulator as Zener diode. So you can see the step-by-step procedure how to do the experiment. So now we are going to start our experiment. So go to the simulation tab and select it. So once you select the simulation tab, you can see Zener diode voltage regulation. So in that first tab is Zener diode line regulation, then its draw circuit, then Zener diode load regulation and its draw circuit, and the last one is Zener diode characteristics. So our experiment is Zener diode characteristics and Zener diode voltage regulation. So for that we have to do Zener diode line regulation, Zener diode load regulation and then Zener diode characteristics. So first I am going to select the Zener diode characteristics. So click to that. So this is your circuit diagram which consists of supply, voltage, series resistance, and this is your ammeter which is used for measuring the current, and this is your voltmeter which is used for measuring the voltage, and this is your Zener diode. So positive and negative side of the Zener diode, and this is your rheostat. And now we are going to see the procedure for Zener diode characteristics. So first step is you have to select the diode. So you have to go to the control window and select this diode. So you can select any one of the Zener diode. So I am selecting the first diode BZX79C5V6. So the voltage is 5.6 volt. Now this is your rheostat value. You have to set this rheostat value to 1 ohm. So you can also go to this instruction tab and you can see the procedure how to perform the experiment. So you will be having all the steps. You can read that instruction and you can perform the experiment. So your first instruction is select a diode, and second instruction you can see this is set the rheostat to 1 ohm, RH to 1 ohm. So we are doing the second step. We have to set this RH. RH is nothing but rheostat value. We have to set it to 1 ohm. So that will be shown in this resistance box here. So you have to set it to 1 ohm. So now the value of RH is 1 ohm. And next step, you have to adjust the rheostat value. So you have to vary this rheostat value, and the voltmeter reading is increased from 0, and in each time note the corresponding reading in the milliammeter. So this is your next step. So you have to change the rheostat value now. So change the rheostat value. Now our voltmeter is showing the voltage value and our ammeter is showing the current value. So these values should be noted in the experimental table. So for that you have to click the add to table button. Now the readings are noted in the experimental table. Similarly, vary to the next value. Rheostat value is adjusted so that the next value is shown in this voltmeter and ammeter. Add this value to the table. So repeat the same for the various values of rheostat. So this is your rheostat. And now we are varying this rheostat value to obtain the voltage and current value. So do the same thing for the various values of RH rheostat. Vary the rheostat value and click add to table so that the values are noted in the experimental table. So do the same thing for the various values by adjusting the rheostat value. Now all these values are noted in the experimental table. So the Zener voltage is recorded, and according to that current value is also noted in the experimental table. Next, we have to plot these values in the graph. So for that, click the plot button. So once you click the plot button, you can see the variations of voltage and current value in this graph. So this is your Zener diode characteristics. And next, we move on to the voltage regulator. So for that, go back and select Zener diode line regulation. So select the first tab, Zener diode line regulation. So you can see this page. So here also you can read the instruction to be followed to perform this Zener diode regulator. So your first procedure is to perform the Zener diode as a regulator. First you have to set the Zener voltage VZ. So you have to set the Zener voltage VZ to 5.1 volt. So you can see the circuit diagram of Zener diode as a line regulation. So first you have to set the VZ to 5.1 volt. So adjust this VZ value and you can see, so this is your Zener diode voltage, which is 5.1. You have to set it to 5.1. So for that you have to click this button and you can vary minutely by the use of arrow mark in the keyboard. So now I have set this value to 5.1. Zener voltage is 5.1. We have set the value. Next, set that series resistance Rs is equal to 1 kilo ohm. So series resistance is Rs, which we have to set as 1 kilo ohm. So adjust the value. So you can show the, you can see the Rs value as 800 ohm. You have to set this as 1 kilo ohm, which means 1000 ohm. So adjust this value. Now I have set this value to 1000 ohm. And next step, you have to set RL is equal to 2 kilo ohm. RL is nothing but load resistance. So load resistance means this value RL you have to set to 2 kilo ohm. So vary this value. 2 kilo ohm means 2000 ohm. So now I have set the value to 2000 ohm. So these are the constant value we have to set in the experimental table. So these are the constant values. Zener voltage, series resistance and load resistance are constant value. And now we have to vary the DC volt. So by varying the DC volt, we can obtain the value of load current, Zener current and regulated output voltage. So these are the ammeter and voltmeters shows the reading of voltages and current. So first you have to set the DC volt to 0, that is minimum value, and then add to the table. Now the values are added to the experimental table. Now vary the DC volt and then click add to table. So you can see the values in the experimental table. Values of load current, Zener current and regulated output voltage value. And now vary the voltage, vary the DC volt. So your varied DC volt is shown in this box VDC, and then obtained values are shown in this concern voltmeter and ammeter boxes. Then click to add to table. Next vary the DC volt. Click add to table. So minute variations also you can do. Vary the DC volt. Click add to table. Then vary it. Click add to table. Do the same procedure. You can see the readings in this experimental table. So that's all. So we have plotted. So we have noted all the readings in the experimental table. Our next step is you have to plot these readings in the graph. So click plot button. You can see the readings are plotted in the graph plot. So here x-axis we are having source voltage and y-axis we are having output voltage. You can see how the source voltages and output voltages are varying in this graph plot. And next, go to the back button or basic electronics lab. Now we can do the Zener diode load regulation. So once you click the Zener diode load regulation, here we have to keep the VDC, that is DC volt, Zener volt and series resistance as constant value. And we have to vary the load resistance and find out the readings. So for that, the first step is for the load regulation. First you have to set DC volt to 6 volt. You can see the instruction by clicking on this instruction window. You can see the procedure to be followed for performing this experiment. So here first step is set DC voltage to 6 volt. That's what we are going to do now. So DC volt you have to set to 6 volt. Yes, now I have set the VDC to 6 volt. You can see the value in this box. And next step, you have to set the series resistance Rs to 100 ohm. So series resistance RS is so you can do the minute variations with clicking to this tab, and by the use of arrow mark in the keyboard I have set this value to 100 ohm series resistance. And the next step is you have to set the Zener voltage to 5.1 volt. So Zener voltage is VZ, we have to set to 5.1. So you can see the Zener voltage VZ in this box. Here the value is 4.8, we have to set to 5.1 volt. So the minute variations, click to this button and arrow mark. Yes, now I have set this value to 5.1 volt. So now the constant values are noted, and now we are going to perform the experiment by varying the load resistance RL. So first you have to keep the load resistance to minimum value and then click to add to table. So once you click to add to table, the values are noted in this experimental table. VDC value, VZ value, RS value are constant values, and we are varying the load resistance RL and finding out the values of load current, Zener current and regulated output voltage. So similarly, vary the load resistance to the next value and click add to table. Readings are noted here. And do the same for the various values of load resistance. So after varying the load resistance and added the values to the table, you can see all the values in this experimental table. So next step is we have to plot all these values in the graph. For that, click plot button. So you will be shown a graph plot which is having load resistance in the x-axis and output voltage in the y-axis. So that's all. We have performed our Zener characteristics and Zener as a voltage regulator. So thanks for watching.